Hello. Yes, today I'm going to talk about simplification with exponents. So, an example, let's say I give an example 2 to the power 3 times 2 to the power 2, right? Even if I don't use any exponent rules right now, I see that we have the same base, 2 and 2. So I can use the exponent rule, but if I choose to use a different rule, like if I could choose to expand it, 2 times 2 times 2, that will give me 8 times 2 times 2, which is 4. 8 times 4 is 32. Right? Do you agree? Now, if I use the exponent rule, I'm going to add the exponents, 3 plus 2, which is 2 to the power 5, which is equal to 32. So as you can see, we received the same answer. But as you know, in math, there are many ways of doing something, and the techniques, the formulas, the rules are ways to find answers. In this case, the exponent rules are for finding shortcuts, simplifying expressions. So you have to understand that every rule, when it comes to multiplication with exponents, division with exponents, let's say I have 5 to the power 3 or 5 to the power 2, right? I can use the exponent rule, which is subtracting the exponents. You have to memorize this, because even if you don't memorize it, you can do it the usual way, which is, I will break it down now. Normally, the way you're taught is to expand it and then simplify it. So I would do 5 times 5 times 5 divided by 5 times 5. Now, I'm going to simplify these 5s, and then I'm left with a 5. Or there's another way of doing it. I can say 5 times 5 times 5 is 125. 5 times 5 is 25. 125 divided by 5 is 5. So I was able to find all those answers that I just worked out right here. But the fastest way is to use the exponent rule. So when we talk about the exponent rule, that's what we mean. So there are many rules, which I will go over. So you have the multiplication, like 6 squared times 6 to the power 3 is gonna be 6 to the power 5. I'm adding the exponents. Now you have, let's say, 12 squared over 12 to the power 5, which is gonna be 12 to the power of negative 3. I subtract the exponents. Now I have an exponent of an exponent, which is, let's say, 3 squared to the power 5. In this case, you multiply. 2 times 5 is 10. So 3 squared to the power 5 is really 3 to the power of 10. Again, if I was to break it down, I can break it down here for everyone to see. So the way I would break it down is 3 squared is just 3 times 3. Right? So that would be 3 times 3. Now, to the power of 5, so that means if we use the distributive in multiplication, so it becomes 3 to the power 5 times 3 to the power 5, and then this becomes 3 times 3 times 3 times 3 times 3, 5 times. This becomes 3 times 3 times 3 times 3, 5 times, right? And if you remember how to write multiplication in exponents, so you count how many 3's you have. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's 3 to the power of 10. So this is just an example that every exponent rule has an explanation. If you break it down, you'll find the answer. But the good thing is that if you have big numbers like to the exponent of 50 to the exponent of 60. You don't need to write every single digit 60 times. You can just use the exponent rules to get the answer much faster. So, which comes down to when you have like a big expression. Now that you know all the exponent rules, and if you have a negative exponent, you flip it to find the answer. It becomes 1/5 squared. This might seem like strange, but if you remember when we have the percentage, right? So if I say 5% is really 0.05. But if you think about it, 5% is 5 divided by 100, or 5 times 10 to the power negative 2. So as you can see, 10 to the power negative 2 is really 1/10 squared. So you can always remind yourself that a negative exponent, you can flip it to get a positive exponent, right? And then from then on, 1/10 squared is just 1/100. 5 divided by 100 is 0.05. So again, now all those rules come into play when we simplify a big expression. Let's say I have 6m times 3m n square. Now if you see a variable that doesn't have, let's say, an exponent, it normally has 1 as an exponent. So 6m, the m has 1 exponent. Now when we multiply the coefficient with the coefficients. So the 6 times 3, that goes together. 6 times 3 is 18. Now I have m times m squared. Now when I multiply with exponents with the same base, always remember, same base, you add the exponent. So 1 plus 2 is 3, so m to the power of 3. Now n is by itself, so we just leave it as it is. If we don't have anything else to match it with, that variable remains the same. So let's pick another example. Negative 6n times 3n to the power of 5, or negative 6n squared, let's say, square. Alright, so negative 6 times 3 is going to be negative 18. N squared times n to the power of 5 is going to be n to the power of 7, because we're adding it. So now, and the same is true when we're doing a division too. So if I come out with something like 21/7, m to the power of 7, m to the power of 11. So the rule of thumb here is that we take care of the constants first, or maybe the coefficients, the one that comes in front of the variable. So 21 and 7 will have to be handled separately. 21 divided by 7 is 3. Now we take care of the numerators first before we go into the denominator. So m squared times m is m to the power of 8 over m to the power of 11. Now we can subtract. Now because they have the same base, different exponent, we can use the exponent rule. So 8 minus 11 is negative 3. So it's 3m to the power of negative 3. So again, it's pretty simple. The only way you get better at this is just practice. So thank you for listening.